Alright, so in this video I took four supercapacitors, connected them in parallel, I charged them up, and I connected them to this little RC car. So now we're going to drive it around and see how long it lasts. So I'm going to do my best to drive this and also to control the car without flipping over. Right? So each capacitor is rated at 2.7 volt at 50 farads, and by connecting four of them in parallel gives me 200 farads at 2.7 volts. If I connect them in series, which I don't need the voltage, if I connect them in series it would actually give me about 13.5 volts at 12.5 farads. But I don't need the power because I've done this previously with one super cap and there was enough power. So what I did is I put four caps in parallel to extend my drive time. So now this is a purely supercapacitor RC car with no lithium battery whatsoever, and I'm driving around USF Research Innovation Center, or Discovery Center I should say, and just want to reiterate, this is a purely supercapacitor RC car with no lithium battery, and it's still going. So my objective here is to exceed the battery duration, the original native battery that came with this. It had like 5 to 10 minute runtime. It was a 3.7 volt, 100 milliamp hour lithium battery, and what I want to do is to exceed that runtime with the four supercapacitors driving this RC car. The great thing about these supercapacitors is, unlike a battery, if you crush it or expose it to extreme hot temperatures, it's not going to explode like a lithium battery. And also, by using supercapacitors, you get more, significantly more charge-discharge cycles. So you can run this a lot longer without depreciating over time, like a lithium battery. If you think about a cell phone, the longer you use your phone and your cell phone and you charge and discharge it, you're going to notice over time your cell phone is going to start taking longer and longer to charge. That's because of the cycle life of the lithium battery in your cell phone. But this, by using supercaps, it has much longer or much more cycles to run. So you'll get more performance out of your supercapacitors than you will with the lithium battery. So we're coming up on the 3-minute mark. This is not going to be a constant runtime because I'm braking and I'm slowing down and turning. So this is just to give you an idea. And when I charge these caps, I charge them at 2.7 volts. And I did a constant voltage method. Constant current method would be more preferred, but I just did a quick and dirty 2.7 volt constant voltage charge. And it took me about 5 minutes to charge these four supercaps in parallel. By connecting them in parallel, this is actually the same as one big supercap at 2.7 volts, but this is total capacitance is 200 farads, where each individual supercapacitor is rated at 50 farads. By connecting 50 farads and four of them together, you have the total capacitance of 200 farads. If you notice, I did hook up a very small solar panel to the front. I haven't done any kind of investigation yet if the solar panel is actually being conducive to the supercapacitor's functionality or charging. And so I'm coming up on the 5-minute mark of runtime. And once again, this is to my objective is to exceed the battery runtime of 10 minutes. So I notice a decrease in the speed and acceleration of the Supercap RC car. So now I'm going to take it back to the office and then do some more experimentation with this project. All right, thank you for your time.